This is Martin Carlisle with the pico-CTF 2017 problem, Weird RSA. We've recovered some data labeled as RSA, but what in the world are DQ and DP? Can you decrypt the ciphertext for us? All right, well here we have the numbers that were given to us. We have C, which is probably ciphertext. P and Q are our two primes, and then we have this DP and DQ, which isn't what you would normally expect to see. All right, so there's a couple ways I could do this. I mean, now that I have P and Q, I could do the normal RSA algorithm. I know what N is. I can compute phi of N. I can do all the things to try to find the key, except the one thing that I don't know is I don't know what the public key was. So that might make this a bit challenging. But I have this DP and DQ instead. So let's look here at the Wikipedia page for RSA. And so if we scroll down a bit, it tells us that there is an efficient algorithm that uses the Chinese Remainder Theorem. And there's DP and DQ, which are D mod P minus 1 and D mod Q minus 1. Now in order to compute the value, we apparently also need Q inverse, which would be the multiplicative inverse of Q mod P. We don't have that, but we can easily compute that. And in order to do that, I'm going to use Python. And so I'm going to Google here for Python modular inverse. Gets me an article from Stack Overflow, which references Wikibooks and gives me this algorithm here. Okay, so with all of that, I've created this little program. So with the Stack Overflow article, I have this modular inverse. I've plugged in the values of P, Q, DP, DQ, and C that we've gotten from our data. We need to know Q inverse, which is the multiplicative inverse of Q mod P. I'm computing that there using this algorithm. I'm going to follow this algorithm. M1 is C raised to the DP mod P. M2 is C raised to the DQ mod Q. H is Q inverse times M1 minus M2 mod P. And M is M2 plus HQ. Right, so I have all those things here. M1, M2, H, and M. Then I could print this out in hexadecimal, and then I'm going to actually decode the hex. So here's the hexadecimal. For the decoding, you'll note I wanted to get rid of that 0x and that L. So I did a slice beginning at 2 to get rid of the 0x and minus 1 at the end to get rid of the L. And then here is my key. There's more than one way to RSA.